Hi, this video is basically about discussion of LCM and HCF. So I'll start from the very basic and we'll take this lecture to some advanced problems and the discussion of those advanced problems. So before we proceed, let me quickly give you the recap of what exactly has been discussed in the past 7 to 8 sessions that have been recorded. We discussed the prime factorization, the nomenclature of the terms, the identification of the prime factorization, and we also did the factorial functions prime factorization. We understood how to find out the number of factors, how to find out the even number of factors, odd number of factors. We did the cyclicity principle and also the remainder theorem. Now coming to the highest common factor, which is also known as greatest common divisor or greatest common factor. These are the same terms used for the same thing. So it's very important because there have been various questions that have been seen on this concept of LCM and HCF. So we should quickly understand this. The first thing is the LCM, the least common multiple. The least common multiple of any group of numbers is basically the smallest number that is a multiple of all the numbers. This basic definition is really important for this because this basic definition gets us acquainted with how to find out the LCM. Let me repeat this once again. The least common multiple is the smallest number that is multiple of all the given numbers. For example, if we were to find out the LCM of 4 and 6, then we can write down the multiples of 4 are 4, 8, 12, 16, 20 and so on. And the multiples of 6 are 6, 12, 18, 24 and so on. Now we can see that there are some common multiples of 4 and 6. For example, 12 is a common multiple as well as 24 is a common multiple. If I write them further, 36 will also be the next common multiple. But the least common multiple means the smallest of them. So the smallest common multiple is 12. So 12 is the number that satisfies the condition. That means it is divisible by 4 as well as 6. Hence we call it LCM. Now let's quickly see what happens when we have more than two numbers. So here is an example. If we have 4, 6 and 10 together, then we can write down the multiples of 4 in one row, multiples of 6 in another row, multiples of 10 in another row. Now we have to see what is the first common multiple of all of them, which is available in all three rows. So we can see that 60 is the first number that is common to all the three rows. That means that is a number which is a multiple of 4 as well as 6 as well as 10. So here the LCM of 4, 6 and 10 becomes 60. Here we have not used a mathematics because this explanation is only intended towards explaining what exactly LCM is. So LCM is the common multiple which is least of its nature. Now let's quickly move to the next slide and understand it better. The least common multiple. How do we do that? We first of all prime factorize the number and then we write down all the prime numbers available in any one of those numbers and with the highest possible exponent of them. That's how we find out the LCM. For example, here we have an example. Let's take a number 4 and 6. We already have seen in the previous slide that the LCM of 4 and 6 is 12. Here we are starting to find out the LCM using the prime factorization. We write 4 as 2 square and then we write 6 as 2 times 3. Now the common prime number is 2, but the LCM says that all the prime factors of the given number with the highest power of those prime factors. So one prime factor is 2, other prime factor is 3. The highest power of 2 available in either of these two numbers is 2. So we have written 2 square here. And the power of 3 that is highest available in either of these numbers is 1. So the LCM becomes 2 square multiplied by 3. On multiplying these two things together, we find out 12, which is the LCM of these two numbers. Now, let's quickly look at the next example, the same example that we discussed in the previous slide. If we have to find out the LCM of 4, 6 and 10, we prime factorize all three numbers. So now we can see that we have three distinct prime numbers to take care of. One is 2, one is 3 and one is 5. So we write 2, 3 and 5. The highest power of 2 available in any one of these three numbers is 2. So LCM takes the power of 2 as 2. The power of 3 is 1. The power of 5, which is maximum available in any number, is 1. So the LCM becomes 2 square times 3 times 5 and that becomes 60. So that is how we intend to find out the LCM of any set of numbers that we have been given. Now the next example, let's see. how do we find out the LCM? Quickly. So suppose we have these 5 numbers, 5, 6, 8, 10 and 12, and if we were to find out the LCM of all these numbers, then what we do, the first thing is, that's my way of finding out the LCM. I usually start looking at the biggest number, which is a multiple of the second biggest number. So the multiple of 12, which is also a multiple of 10, multiple of 12, so I have written multiple of 12 here. So the first multiple of 12 that is also divisible by the second largest number is 60. That means the LCM of 12 and 10 becomes a 60. Now I do the same process again. Now I have to see the next multiple of 60, which is divisible by 8. Here we can think about the prime factorization as well, because if you look at the 60, 60 is 4 multiplied by 15 and 4 is 2 square times 3 times 5, and for the number to be now divisible by 8, we need minimum power of 2 as 3, so we have to just multiply it by 2, so that the resultant becomes 120, and that is the multiple of the 3 biggest numbers, 120. We once again think the next multiple of 120, that is also divisible by 6. So we see 120 is already divisible by 6, and likewise 120 is already divisible by 5. Therefore 120 becomes the LCM of all these 5 numbers. I repeat once again, in short, in brief, we start looking at the multiple of the biggest number in the series, the multiple of 12, that is also a multiple of 10. That means the second biggest number is 60. Then we start counting the table of 60 and see the multiple of 60 that is also divisible by the next largest number, which is 8, is 120, and 120 satisfies the other case. If it were not satisfying the other case, we once again would have looked at the multiples of 120 which had satisfied the next largest number in the series. So this in totality gives us LCM very quickly, and we can solve such LCM calculations even mentally. Moving on. Now we have to discuss the greatest common divisor or the highest common factor. These terms are synonymously used, so we should be well acquainted with these two terms. The greatest common factor is the highest common factor. Now we can already see that in its name already, we can see that it's the biggest number, it's the highest and common factor. That means it's a factor of all the given numbers and it's highest of its type. So let's once again look at example and figure it out. Let's look at the numbers 4 and 6. The factors of 4 will be these 3 numbers 1, 2 and 4. If we write the factors of 6, then we'll have 4 numbers 1, 2, 3, 6. So we see 1 is one of the common factors of these two numbers, 2 is also a common factor of these two numbers, and there is no other common factor. So we have two common factors 1 and 2, and the highest of them is 2. So the highest common factor of these two numbers become 2. Now, highest common factor in short can be explained as the biggest number that can divide all the numbers given in the set without leaving any remainder. So once again, let's look at another example. So now we have taken two numbers 16 and 20. The factors of 16 are 1, 2, 4, 8, 16. Factors of 20 are 1, 2, 4, 5, 10, 20. Let us see what is the biggest common factor. If we carefully look at these two things, we figure out that 4 is the common factor to both the numbers, and that's the biggest common factor. Although we have other common factors like 1 and 2 as well, but the biggest one of them is 4. So 4 becomes the highest common factor. This was basic understanding of highest common factor. Next, we will learn how to find out the highest common factor mathematically. So moving on, we have the next slide here. So the GCD. To calculate the GCD, what we do is we once again prime factorize the number and we look at the highest common power of those prime factors which are available in all the numbers. That means we have to look at the common factors and the highest common power that is available. So let's take the example of 56 and 96. 56 when prime factorized becomes 2 cubed times 7. 96 becomes 2 to the power 5 times 3. What is the common prime factor here? 7 is not common because it's not in 96. 3 is not common because 3 is not in 56. So 2 is the only common prime factor. And the highest power of 2 that's common to both the numbers is 3. So the highest common factor of 56 and 96 becomes 2 cubed, which is 8. Once again, let's look at another example. If we have numbers like 4, 6 and 10, then the only common prime factor among these three numbers is 2, and the highest power of 2 that is available in each of one of these numbers is 1. So the highest common factor becomes 2 raised to the power 1. So that is how mathematically we find out the highest common factor of any given set of numbers. Now we will once again utilize these principles to answer even more difficult questions, which I have already put into the slideshow. So let's move on. Here we have one of the questions, and if you are watching this video, then I insist that you pause the video, you answer this question yourself, and then you look at the explanation how I'm giving it to you. Okay, if you have given it a try, then here is the explanation. The question is, what is the minimum number of square tiles of integer side length needed to cover the floor of 16 by 20 square feet? No tile is to be broken to cover the floor. Now we have to find out the minimum number of square tiles. Now the question is, how do we find out the minimum number of tiles needed to cover the floor? Then the answer is the number of tiles will be minimum if size of the tile is as big as possible. So let me take you to the next slide, which gives you the explanation. So here, no tile is to be broken. So the side of the tile should be a number that is a factor of 16 and 20 both. Let me repeat that once again. For minimum number of tiles, the length of the side should be as big as possible. And the length should also be able to divide 16 and 20 both, because it should be a factor of 16 and 20, because no tile has to be broken. So the length of the tile should be a factor of 16 and 20, and it should be as big as possible. So basically we are looking at the common factor that is highest of its nature. So we come to this principle that side of the tile will be the highest common factor of 16 and 20. Now we have already seen how to find out the highest common factor of any given set of numbers. 16 is written as 2 to the power 4, 20 is written as 2 square times 5. So the common prime number that we have here is equal to 2, and the highest power of 2 that is available to both the numbers is 2 again. So the highest common factor becomes 4. This is the length of the side of a tile. Now the number of tiles that are needed to cover the floor will be on the dimension 16. We need 4 tiles because 16 can be covered by 4 tiles on that side, and the side 20 can be covered with 5 tiles, because 20 when divided by one tile side length, which is 4, becomes 5. That means there are 5 tiles that can be put on the length 20. So the total number of tiles that we have is 4 times 5, which is 20, and that becomes our answer. Now having solved this question, let's quickly move on, and here is the next question. Suggestion is once again the same, so I insist that you pause the video, you solve this question yourself, and then you look at the solution. Alright, now let's discuss the solution. Let's understand the question first. There are 3 friends, A, B, C, D, E. These are 5 friends. They have some chocolates. If the chocolates are to be shared equally among A, B, C, and D, only then there is one chocolate left unshared. So this is the first statement that needs to be understood, that if the chocolates are shared among 4 people, then there is always one chocolate to be left. That means it has to be a multiple of 4 plus 1 form, and if all 5 of them share the chocolates equally, then they have one chocolate left to be shared. That means the total number of chocolates should also be a multiple of 5 plus 1 type. And since we are talking about the same number of chocolate, so those chocolates should be equal to 4a plus 1, and that should also be equal to 5b plus 1. That is how we formulate the given information first before we answer the question. Let me take you to the next slide, and there is the complete explanation. So here it is. The number of chocolates shared among 4 of them has to be a multiple of 4 plus 1. Similarly, the number of chocolates should be a multiple of 5 plus 1. That means if this 1 is out, then the remaining number of chocolates should be a multiple of 4 as well as 5. And the question is talking about the least number of such chocolate. That means you have to find out the least multiple of 4 and 5, least common multiple of 4 and 5. So the multiple of 4 and 5, that is least, is 20. LCM of 4 and 5 plus 1 satisfies this condition of one chocolate left over again and again, and so the result becomes 21 chocolate, which is option D, and that becomes our answer. So the previous question was based at calculation of HCF, whereas this question was based at the calculation of LCM. Now let's quickly move on. So Here are several mistakes that some of the students make, and the suggestion is that we should just try to avoid these mistakes if possible. One is getting confused with different names of LCM and HCF. GCD, HCF are the same thing. LCM is used uniquely. Now, not having prime factorization as the default approach is not really a great thing. However, in LCM, we can always start from the multiple of the biggest number, like I shared in one of the questions. And the third mistake that we should be avoiding is that we should be uh, very careful about the constraints given in LCM and HCF. For example, in previous question, it was given that there is one chocolate left always. So we should always be careful about such constraints while answering the question. Okay, moving on. Now, let's quickly discuss one of the very frequently used property of LCM and HCF. So, to discuss about that property, I'm just quickly discussing one of the examples first. Here, we are taking these two numbers, one is 56 and the other is 96. We have already seen the prime factorization and we have already calculated their HCF and LCM both. The highest common factor of these two numbers becomes 2 to the power 3. The LCM of these two numbers becomes 2 to the power 5, 3, 7. I can repeat once again, in LCM we consider all the prime numbers with their highest available power. In HCF we consider only the common prime number with the highest common power. So the only common prime number is 2 and the highest common power of 2 is 3. While for LCM we consider all the prime numbers, which are 2, 3 and 7, all three of them, and the highest power of 2 that we have here is 5, so that becomes the LCM. If you carefully look at the LCM, HCF and these two numbers, then you can just observe the one relation is that the product of these two numbers is always equal to the product of LCM and HCF. So from here we derive this property that for any two given numbers, the multiplication of their LCM and HCF will always be equal to the product of those two numbers. And we consider this property to be a really important property because in various actual GMAT questions, the property has been quite instrumental. Now, having discussed this, let's quickly move on to one of the questions. So here is a question: if x and y are positive integers, what is the value of x into y? So the first statement says the greatest common factor of x and y is 10, and the second says the least common multiple of x and y is 180. It's a data sufficiency question, so we have these 5 options. I suggest that you take your time, answer this question, and then see the explanation. So here comes the explanation. We already have the question here that we have to find out the product of those two numbers, and we already know, looking at this statement, that the product of two numbers is always equal to the product of their LCM and HCF. The first statement says that the greatest common factor of x and y is 10. So in absence of LCM, this can be said insufficient. However, it's really important in data sufficiency to prove the statement is not sufficient if you feel that statement is not sufficient. So here I have taken several cases that will prove that it's insufficient because it renders inconsistent answer. Now we have to keep, according to the first statement, the greatest common factor of two numbers is 10. So first case is when x is 10 and y is 20, then the product becomes 200. And the second case is when x is 10 and y is 30. Again, the highest common factor is 10, but the product becomes 300. And here we can eliminate two options, option A and D, because the first statement is not sufficient, so each statement alone also cannot be sufficient. Now let's look at statement 2. Statement 2 is the least common multiple of x and y is 180. So once again, because we do not have the information about the highest common factor, so this is not going to be sufficient, but let's quickly take a few cases and then prove why it is not sufficient. Case 1, when x is 10 and y is 36, then their LCM is 180 while their multiplication is 360. But in case 2, while the numbers x and y are 5 and 180 respectively, the product is 900 and LCM is still 180. Since there are inconsistent values of x into y, therefore the second statement also is not sufficient. Now we can eliminate option B as well in addition to A and D. So 3 options are out. Now we have to combine the two statements, and we already know the property that the GCD multiplied by the LCM of the two numbers is equal to the product of two numbers, and there we get our answer that the multiplication of these two numbers becomes 1800, and that gives us answer option E. Now, having discussed this question, let's quickly move on to the next question. That's question number 2. Here once again we have been given some information in terms of the greatest common factor and least common multiple, and we have been asked whether the multiplication of the two numbers is divisible by 8. So the process is going to remain same, so I'll quickly explain this. The first statement is the greatest common factor of x and y is 10, so we can take multiple scenarios and then prove that the statement together are not sufficient, because we have taken one of the cases. It is 100a. Now 100a, for example, you have taken the LCM. The greatest common factor of x and y is 10, and the LCM is always a multiple of greatest common factor. That's another really important thing that we should be careful about. So since GCD is 10 and LCM is multiple of 10, so the product has to be 100 times some other number. But this number a, since it is unknown, therefore we are not sure whether this 100a is going to be divisible by 8 or not. If a is not even, then it's not divisible by 8, but if a is even, then 100a will be divisible by 8. Therefore the first statement is not sufficient. Second statement only confirms that the LCM of the two numbers is 100. Now we can take two numbers. We can take some examples as well. If the LCM is 100, we cannot say what the GCD is. For example, for LCM 100, one of the possible set of values could be 4 and 25, and one of the possible values could be 4 and 100 itself. So 4 and 25 when multiplied together does not result in something that is divisible by 8, but 4 into 100 results in a number that is divisible by 8. Therefore, the second statement again is not sufficient. Now, the moment we combine the two statements, we understand that LCM into HCF gives us the product of those two numbers, x into y, and therefore x into y becomes 10 times 100, that is 1000, which is divisible by 8. So the answer is definitely yes, and so it is sufficient to answer the question, and the answer becomes option C. Now, there is one more question here. Let's quickly see to it. The question is, what is the greatest common divisor of the distinct positive integers a and b? We have to find out the highest common factor of the two numbers. Now, the first statement. Let's look at the solution. The first statement says a and b share exactly one common factor. Now, from the examples that we have done, that we have solved together, there is one observation to make, that 1 is always a common factor between any two numbers that you choose. And if there is exactly one common factor, then it certainly has to be 1. And in that case, the greatest common divisor of the two numbers becomes 1, and therefore the first statement alone is sufficient to answer the question. Let's look at the second statement. A and b are both prime numbers. So if you consider any two prime numbers, the prime numbers are the numbers which have exactly two factors. First is 1, second the number itself. Now, between any two prime numbers, and we already know that they are distinct, then the only common factor between those two prime numbers can be only 1, because there is no other common factor between any two prime numbers. So once again the second statement also becomes sufficient, and the answer becomes option D. Here we have another question, and it is an official question of the GMAT as well. If x and y are the positive integers such that x is 8y plus 12, then what is the greatest common divisor of x and y? We have been given some information. Let's look at the explanation. The first statement is that x is a multiple of 12. So 8y has to be a multiple of 12. So x is a multiple of 12. Why? Because if x is a multiple of 12, then in 12 we have to add another multiple of 12 only to get the result that is also a multiple of 12. So 8y also has to be a multiple of 12, which means that y definitely has to be a multiple of 3. But since y may be an even multiple of 3 as well as an odd multiple of 3, therefore the GCD will continue to differ, and hence we can say that the first statement alone is not sufficient to answer the question. While if you use the second statement, which says that y is a multiple of 12, then I guess the easiest thing is that we could assume some values of y such as 12, 24, 36. Substituting those values of y in this principal equation, we can find out the values of x, and in each case when we see the greatest common divisor of x and y, then every time it is 12, leading us to a unique answer of the question. Therefore the answer becomes option B. That means the second statement alone is sufficient to answer the question. So we have another question here, and but I guess that this session has already been quite lengthy, so I will leave light here, and you can try this question yourself, and you can see its explanation in the other dedicated video as well. Thank you so much for watching this video on LCM and HCF, and I am Bhupendra Singh, and I was taking this session. So on behalf of GMAT Insight, thank you so much for watching these videos. Thank you.